Okay, I hope you can see the my Eclipse editor. Can you write yes for that? Okay, few people already wrote the yes. Okay, fine. So what we are going to do today is very interesting stuff. We are going to look at some problems, but more than problem, we are looking at the concept of iteration versus recursion. Okay, so this is the main discussion topic for today's session. In 1 hour session, we are going to look at two problems where we can write a programming language in two different ways, that is iteration, and one is recursive programming. So these are two different type of programming. Both has been highly used in competitive programming as well. So without further delay, we will start the session. So first is Fibonacci series. That is the first thing. So I want to know, does anyone know what is Fibonacci series? Please, can you write yes and no in the chat? Fibonacci series. Okay. Okay, nice, awesome. So what Fibonacci series actually, exactly, correct. So what the Fibonacci series is, it's a very interesting series, and it's quite many times people have asked it in the programming questions, programming challenges, as well as interviews, and we are going to look at very interesting aspects of it from the lens of iteration and recursion. We will code it. We will code both type of algorithms, and we will see the pros and cons of that. Okay, so what Fibonacci series actually is it's a series of number which starts with 0 and 1, and the next number will be is addition of first two number, the previous two numbers. So in this case 0 plus 1 is 1. So now if I have to add ninth number, then I have to take addition of previous two number, in this case 1 and 1. So if I do that, 2. So actually someone has already did that, so that's awesome. So next number will be 3, considering addition is 2 plus 1 is equal to 3. Similarly 5, because of 2 plus 3, 8 because of 5 plus 3, just like that it will go on till infinity. Okay, that's how it is, and then we are going to see how it is going to be written. Okay, someone has given some background of it, Priya. Thanks, Priya. So now we will see that how to write in a program way, especially in Java. And interesting stuff we will do is we will start with basic algorithms. We will see how we can write it in an iteration way. I think iteration is quite easy. Recursion is something many people doesn't understand during the initial stage, but we'll see the advantage or disadvantage of using that recursion as well. Okay, so let's start with it. So if you can see that always we have some predefined number here, that is 0, 1. It will start with 0 and 1. So what we will do is we will create some variables to store such numbers. So I am writing right now, it's a iterative program. So what I will do, since I am going to write iterative versus recursion, I will come back to discussion what exactly recursion is. So it's better to write directly write in the main. I will create a separate function for that. So what I will do, private static int main int 10. Okay, so sorry, I have wrote the main wrong. It's Fibonacci iter. Okay, so I've created a function name called Fibonacci iter. It's basically for writing the code in an iterative fashion, and I will write the main code here. So before that, I need some numbers. So usually how they ask us generate a Fibonacci series till the nth number. So when we say nth number, here we can define any number. So I will say 10 for instance. So when I am asking 10, that means if we have to count from here 0, 1, 2, 3. So if we find the 10th number in the series of this Fibonacci, so in this case will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So 55th is the 55 is the 10th number. That's how it is going to be. So to calculate that using programmatically, we are writing first we are writing a iterative function in the as a method. So what we are going to do is int num. We will define some of the variables to just to be clear what exactly why we need it. We will tell that. Okay. So I will write a for loop where I will take 0 to n. That is the number I am passing directly to that, and I plus plus. Okay, I have to write sum as well. So I will do that, and then I will write. So what I have to do is, since I am taking num1 and num2 as previous two numbers, so I have to store some values in it. So to do that, what I will do here is I will take, since I know that the first two numbers are 0 and 1, so I will hard code those things, so such that I will get the values of num1 and num2. That is the first two numbers in the series. Now what I have to do here is I have to till I have to find a particular number, so I have to calculate that thing. So sum is equal to n1 plus n2. Say num1 plus num2. So this is the base core. This is a core logic where I am calculating the series based on its previous number. Okay, so that's how it will be. And then since I am calculating the sum, now once I get a number, suppose I am getting 0 and 1, so I will just write it here. If I have num1 as 0 and num2 as 1, so obviously sum will be 1, correct? But I have to create a series out of it. So what I will do, I have to change the number. So what I will do is, I will now num1 will become num2, and sum will become and num2 will become sum. So we have to add that thing. So it's a very simple code. So sum. So I will just write it that logically here. Num1 will what is the value of num2 will be transferred to num1, and what is the value of num2 will be transferred by sum. Okay, that's it. That's the code. And since I am sending the number, I will just return the value sum. And since I have to call the number, I have to call that function Fibonacci iter. I will just call it from here, Fibonacci iter, and then just passing the value till which number I want to get the numbers. Okay, so that's the simplest thing I am going to do here, and I am going to do sum equal to 0. Okay, that will be fine. Okay, now we have written a very simple code. We will run through it, but just see whether it will work or not. So let's save it and then let's run it. Okay. Why it's not running? Just a minute. Just a minute, I think why this is not running. Okay, let's see. I have this Fibonacci here. Okay, coverage is fine. Console is not opening. Okay, I think some issue is coming. Okay, what I will do, I will just create another file just for the namesake. I'll just copy the code. Fibonacci 1. I'll just have it like that. Just copy paste the whole thing. Okay, let's see, now it should run. It's not running. Okay, let's see the problem where it is happening, why it is not running. If I just write the code, all of it typically here, and I will just don't call this. So what? So you have to again identify that why it's happening. No, the private static should ideally work considering it's a function inside the class itself. I don't have to create a object. Fibonacci iter, it's quite fine, I guess. Okay, let's see. Okay, I'm getting some errors here. Let's get. I will just system.out.println, and I will just write some. So what I did it, I'm not right now I'm not calling any function, I'm just directly copy paste the whole code in the main, and let's see whether it will run or not. I have to identify why it's not running. Yeah, it is running, so I have to figure out where I have gone wrong. Okay, iteration start with 2. Yeah, correct. So what, okay, so some people are retelling the problem with the code. Exactly. So the answer came right now is 89 instead of 55. So why it happened here is because I already take first two numbers as num1 and num1 0 and num2 as 1. So instead of trying this, if I try from 2, I think it should work pretty much fine. 34. Is it the correct answer? Okay, if I take 1, so someone has given I equal to 2, but it's not running. Now it is coming fine. So if the people who are saying I equal to 2, why can you tell me the why reason it's not worked there? So when I did, so I should, yeah, you should also specify that if I'm taking 2, I have to do I less than equal to num as well. That's correct. Okay, now let's try to identify another problem. So our program is running, but it's not callable. So what should we do here? Let's see that. So someone has suggested in the chat that I should do. I should make it public. So if I do that, so instead of private, I will do the public static int. So whether it will work here or not. Okay, it will not work, obviously. Okay, it's not showing any value. The reason it's okay. Can you identify what is wrong with my code? I have identified the thing. Okay, let's delete certain things here. Yeah, now the code is all there. System out dot not there, no print. Okay, yeah, print is okay. I will do that print. I will add the statement. Anything else? I think one major thing I didn't do that. I found out what I didn't write it here. Okay, print statement is not there. I agreed. Void to int. It's already int here, right? We are not. Yeah, we are not right now. We are not showing entire series. We are just showing it as a numbers. Entire series is something I think people can do it. They're showing the last number. exactly, didn't catch the return value. I didn't wrote any value here. So instead of writing as a return value, I will do system dot out dot println. So the mistake I did is I was returning some value, but I am not storing it anywhere. So instead of doing that, what I am doing, instead of creating another variable, I am just system.println and I am putting directly the value there. So print value is also the correct answer. Okay, so if we just run it here one more time, the value is coming 89. I just have to change the code in for loop here. I will just need to change to 1 or maybe 2 for better understanding, and I will take it as I less than equal to n. Okay, now it's coming. Okay, so for those people who didn't understand the logic, I will just quickly repeat through what I did here. It's an iterative code. So when we say iterative, that means we are using for loop or while loops. We are using iterative statements. So for example, right now I am taking n is equal to 5. Here num is equal to 5, and that means n is equal to 5. So I need the top 5 elements of the series or nth Fibonacci number according to my code. Okay. Now what we have to do here is, the first two numbers are already defined. This is the first number of Fibonacci and this is the second number. So for third number, I have to calculate the third number, I should know the previous two numbers. So that's why I wrote it sum num1 equal to num2. So in the first loop, what it will do is, the sum value will be, and considering that I am keeping n as 5, so sum value will be is equal to 1. So now once I got a number 1 as a series, I will write it here better, 0 1 1. I got the third number. Now to calculate the fourth number, I should consider these two numbers only. I should not consider 0. So what I am doing, since earlier this first one is equal to num2, so I am storing that value in num1, and whatever the value I got from sum, I am transferring to num2. Similarly, in the second iteration, when I equal to 3, it is less than 5, the sum will become 1 plus 1 equal to 2. So I will go for 2. Then similarly I will go for 3. Similarly I go for 4. So that's how the values will come. 5. That's how the value will come. Now all this is fine, but now the interesting thing will come. Now we have to analyze our code. What kind of analysis we should do here is, now if I am writing 5, it's all fine, but what about 10? If I write number as 1, I want to know 10th number of Fibonacci. It is taking 55, it's still fine, but I want to observe something more. Let's see whether you can do it or not. Okay, I will take it. Now I want to know 20th number of the Fibonacci series. 6765, still fine. Let's take n equal to 50, num equal to I want to know 50th number of the Fibonacci series. Okay, now I am getting a negative value. So can someone think of why the negative value is coming? You people can write in the chat. So I want to know that. I want to know 50th position of the Fibonacci series, but it is coming. Okay, so answer is int ranges over. Okay, to solve that, I will make it as long. Okay, I will return long numbers. Do that. Let's run one more time. Okay, something came. Okay, I will not show the error, but can someone identify what's the error? Oh, sum is still in. Okay, you people identified. Yeah, you are very smart people. Okay, so let's do long. So what the error was there, that long, I was returning an integer variable, but it expecting a long variable value. So so based on that I'm using long. So now I think everything would be fine. Let's run it again. Okay, some still values are coming in function. Okay, now the problem is coming here is some value is long but num2 is int, so I have to change those number as long as well. Okay, still some issue is coming. So what's the issue? Okay, you have to take 1/3 variable, parameter is integer. Nice, so I will take it here. Okay, so into long, yes, I have done that. Okay, thank you so much. Now I want, okay, that's how you debug the code. That is also you can look at it. So I might not remember the code, so again I have to debug. I might think that it's still a simple program, but I did lots of mistakes, and without your help I think I might take a lot of time. So again, you should know where the problem should be. So you have to keep reading the error message properly, and then you have to start thinking of how to solve it. So till now it is also good, and you can get a long number. Okay, now let's see the recursive fashion here. Okay, I want to remember why we did this, because it will be very useful when we are going to know the recursion. Okay, so I hope you have observed that we have tried with multiple numbers, and we are getting bigger, larger and larger values over the period of time. Okay, so Fibonacci series, or if you, as you increase the more, if you want more and more number, at that point of time you will get higher and higher value, and it is increasing drastically. That means only the 50th number of Fibonacci series, I don't know, it's more than maybe crore, maybe billions, maybe it is in the range of that. So that's how exponentially the value is growing. So I wanted to remember this aspect, because when we do a little bit analysis of recursive code, you might appreciate why we are doing this. And if some people remember, this certain thing called as optimization, which we have discussed in the first session. So when we are writing code, after writing something, you have to optimize few things, we have to tweak few things. So we will going to look at that over the period of time. So we will use that with recursive function as well. So let's write the recursive function right now. So what is recursive is basically you are calling, I will just use a console. Okay, so when you say recursive function, basically you are calling the function again, but basically for a sub problem. So if I have to say P1, as a P1 I have a problem. Now instead of writing a proper algorithm, I can use the same code of what I have wrote for P1, but now I will divide the problem into I have a P problem, and then I will divide the problem into P1, P2, like that, Pn task. So these problems are sub problems. We will see that what are the problems would be in terms of Fibonacci, but as an intuition you have to see this. So I have a P problem, okay, in this case Fibonacci series. Now I have written the whole code. Now again I don't have to think of writing some more and more codes. I have to use the same code and try to solve that problem in a very quick way. Okay, to do that, we divide the problem into sub problems, and then we try to solve those sub problems. So recursion will help you to achieve that thing. It is it's, as an intuition wise, it's quite different from iteration, where the code is written and you keep on running the same code again. You will do that, but the number of lines for code will be increased. Right now maybe smaller codes you might not appreciate it, but as you go more and more detail in data structures, you will find that for certain code you have to write a lot, but for recursion you will find that you just need to write 3 or 4 lines of code. After that you will realize that Okay, it's quite readable, and it saves a lot of time for, as a developer, for you to write the code. We will see that how it is going to do that. So again, if I have to say a Fibonacci series and I have to make it as, I have to give certain kind of notation, I will say that I have a Fibo series. I have a number n. Okay, to get the nth value of a Fibo series, I need to look back at the n minus 1. I have to look back its two previous numbers. So I have to find what are the two previous numbers of that series. So that is n minus 1 and n minus 2. Then again, if I have to find that what is this n minus 1, I might have to look at its previous two values, that is n minus 2, Fibo n minus 3. Okay, and so on. So the notation what I am saying is, if I have a number called 5, to get to know how I able to reach to 5, I should know its previous two values, that is 3 plus 2, and to get to know how the 3 came, I should know that 2 plus 1, and to get to know that how I came able to get to 2, I should know that it came from 1 plus 1, just like that, and then I will able to see that to get to 1, I should know that it should come from 0 plus 1. So that is the intuition of recursion, where to reach to a 5 state, we are coming down to we going down to sub problems and try to understand from where it starts. So it's a kind, you can think it as a kind of reverse action as well. Okay, instead of building from, okay, I will add 0 plus 1, then 1 plus 1, like that, you will try to go back to the original thing. From there you start building and top and get a recursive function out of it. Okay, so that's an intuition for recursion. That is, you're trying to, for a problem, you're trying to create some sub problems. That sub problem, the code of the sub problem will be same, and you're going to evaluate it again and again till you reach to get a proper value. Okay, that's the intuition for now. Let's start writing the code of Fibonacci in recursive, then you may start appreciate what we are talking about. So private static void. So again, since I'm using Java, I should create an object, but I'm not creating because I'm making a static variable, static function. I hope you have observed that. I did, even though we say that we need objects, but I'm not using objects because I am using a static keyword. So it doesn't, I can call it without even creating an object. Okay, so the concept is same. So when I said recursion, I should, as someone has written, function which call itself. So I have to write a code in a certain way such that I should call the same function. Okay, I wrote the function, but function not proper function name. So I will write Fibonacci recur. Okay, that's a function name of mine. So what I will do is, I will just call Fibonacci n plus Fibonacci n minus 1. I think, yeah, that would be fine enough, I guess. Okay, let's see, it will work or not. So before that, I should know, okay, Fibonacci recur, I should call a function name. Okay, now what we have written is something we are calling we were trying to get the Fibonacci number of num. To get to that, we are calling two functions which is same as Fibonacci number, where they calculate the what is the position of Fibonacci number and num minus 1 and num minus 2, just like this. Like to get to a 5, we should know what is in fourth position. That is the number will be 3, and then in third position the number will be 2, just like that. Now another concept that you should know in the recursive function is something called as base condition. So what is happening is, as you try to trace it back to the smallest sub problem, you should have a base condition where it will stop. Otherwise, if you don't provide any base condition at that point of time, it will go for, without base condition, it will go for infinite loop. So we should have a base condition here. So what the base condition here is, if num value is less than greater than less than equal to 1, I am just returning num value. So what does it means is, the moment I got num value as 0, I will return 0 value. The moment I got num value as 1, I will return 1. That is these are the smallest two base condition that I am having, and these are the hard code. And if you observe in the iterative function, these are the first two numbers that we have hard coded it, because that's a base condition that we should have in iterative function as well. Without it, we can't calculate. We can't calculate it properly, right? So that base condition is coming here. So the base condition here, again, to combine it, base condition gives you a power to tell the compiler that till what step you have to call the function and where to stop. So whenever I am saying these two numbers, I will stop directly. Okay. If you are not able to get till now, just let me know. We will when we will do a little bit more analysis, I can able to help you out more. Okay. Now what I will do here is, in the main function. Okay, in the main function, I am keeping everything same. I am just changing the function call, and let's see, I will keep the value num as 10 or maybe 6. So I want to know 6th position of it. So let's see what the number would be. Oh, the number would be 8. So is it correct? Let's see that. So I have 0, 1, 1, 2, 3, 5, 8. So yeah, this is 6, considering we are not considering 0 as the number in the series. Like we are starting with 1, we are getting like this. Okay. So what is happening here? When I put I want to know 6th position of the Fibonacci series, I am getting 8 value. So what it is doing here is, let's see this analysis very carefully. Again, I am calling the function itself. I am calling the Fibonacci recur itself, and how I am calling here is, I am call for nth value, I am calling its n-1 and n-2 functions. Okay. So when I say I have num equal to 6, so what I am calling here is, I'll just copy it. Okay. So if Fibonacci is like this, I am calling its num, that is Fibonacci recur for the 5th position and Fibonacci recur for 4th position. Then if I go down, if I go for Fibonacci 4 at 5th position, if I do this, then what I will have is Fibonacci 4, Fibonacci 3. Again, if I go for 4, so you can see that I am calling the same function multiple times at different places just to calculate a certain value. 3 and Fibonacci 2. So I am calling its previous two values to get to know these things. So Fibonacci for 3, 2 plus 1. Okay, so this is how we are going in a recursion value, stack by stack, lower by lower, we are going in step until we reach a base condition where we are saying that here at Fibonacci recur 1, the value of num will be equal to 1. So it will touch this condition, that is a base condition, and then it will return num value. Okay, so once it returns the 1 value, I can write it here as the value as 1. Okay, so for Fibonacci 2, when it, if you go again, I will go for 1 plus 0. Okay, so if I calculate this Fibonacci 1 and 0, so for that it is returning only num value as it is. So whatever the value of here is 0, so it will return 0. It is the value is 1, it is returning 1, and it is calculating the here itself. So for Fibonacci 2, I am getting a value of 1. So I will add it here as 1. So 1 plus 1, I am getting a value here as 3. Say 2. Similarly, I will copy this 2 value here in Fibonacci third one. Okay, sorry, 2, and Fibonacci 2 value here is 1 already. So that's how I'm getting the values, and again it is going up. So if you can see here is I'm getting 0 plus 1 value, 1 plus 1, same thing I'm getting using a recursive function method. Okay, so that's the intuition for this. Now let's do some more analysis here. So if we try to call the number, so for num6 I'm getting 8 value. If I increase the value, okay, so someone is asking return should be under else. Yeah, if you want, you can have it as a else condition, otherwise without else also it will be working perfectly fine. If I wrote only for the base condition, this is the base condition, and base condition is needed for all the recursive function. You to tell that where it should stop, because if I don't have a base condition here, so what it will do here is if I write 0, so it will go num minus 1. Since integer can take negative value, it will take it as minus 1, and then it will go for minus 2, and so on. It will go like that. It will go till the memory doesn't exist. Memory will say it has been exhausted. So it will go that to stop to go to the minus numbers. It is we are making here giving as a base condition. Okay. So yeah, so for 10th value we are getting this. So if I increase the number of values over time for Fibonacci, okay, 6, 10. If I increase to 20, let's take, oh sorry, if I take the value of 30, I want to observe how much time it is taking to display the number. See, it's still taking time. It's taking a lot of time. Now it came. So if I increase more values, if I am not even printing, I am just want to know the position of the 50th position on the Fibonacci series, and it is taking a lot of time. Still it is still coming. It's still calculating the stuff. Still it doesn't came. Okay, so by the time the results come, I want to know that if you have remember for the iterative function, when we write num equal to 50, you got the very quickly the answer you got very quickly. So but why for recursive function, even though you're trying to write for the 50, it is taking so much time that till now it didn't came. So can anyone answer that why the recursive function is taking time? It is also giving a correct answer, but why it might be taking more and more time? Can you please write that in the chat? I think by the time you write an answer also, still it will not come. For iterative it is working perfectly fine, but for Fibonacci, okay, stack call function again and again of n square. Okay, any other answer for that? So I want to know that, see, I have written, I want to know 50th position of Fibonacci series. When I did for iterative function, it came very, very quickly, maybe in a 1 second. But for recursive function, it's taking a lot of time, that much time that I still am not able to get an answer. It's still running in the background. Why do you think that? Let's see at what time it will come. But multiple recursion, okay, that's almost correct. Stack memory, okay. Anything else? You're going too much into detail, but it is written in your screen only, and someone has answered, but still I want to know different perspective of the same answers. It takes lots of values. Exactly, correct. You're almost coming there. So again, so what some of your friends are telling here is, if you observe this only statement, this function call for 6, to get to know the position of 6th value in a Fibonacci series, I'm calling one function at least twice. So suppose Fibonacci 4 is there, so I'm calling it at least twice, either first for the case of calculating the 5th position, and then again to calculate the 4, I'm again calling it like that, calling the Fibonacci at the 4th position. Or if you want to see in more detail, you can see here the highlighted part, here 5 equal to 3 plus 2, 3 is again has been called, now 2 has been again be called. So it is calling again, the function is called is being called again and again without stopping. It is so much time that till, even though we have, maybe I have started running it 2 or 3 minutes back, it's still running in the background. So it might take maybe more time. So still, why people prefer, the question we should ask here is, yeah, we will look at dynamic approach. That's a very big concept, but interesting concept, but we will come to that point. But still people prefer writing recursive code as well. So anyone can think that why, like, even though it's taking too much time, we have seen even for such a simple problem as Fibonacci series, it is taking a lot of time, even which can be written by a simple iterative function. So can one think that why still prefer recursive code? People write recursive code a lot to break a question, okay, to break a problem, basically, if I'm understanding correctly. Anything else that people like, why still, what can you think that why people might be using? I'm showing a bad side of recursive code here, that I was asking for something iterative for a lot of time, but recursive is still taking, I don't know how much time it will take to just to know that. Just write a couple things and then write some to reduce number of lines. Yes, exactly. So if you just observe this line of code, it may be 10 lines of code, the highlighted part. This is for iterative function, okay. And if you just observe this highlighted part, is just 3 or 4 line of functions, okay. So if you're thinking like, if you become a software engineer, you have to write a lot of code, and you will not be interested to write such big line of, since it's a basic problem, you might think that, okay, what is the difference between 10 and 3? But if you go there, work in the software industry, at that point of time, you will realize that you have to write thousands of lines of code. At that point, you want to write as scripts as possible, and it will save a lot of time to you if you are very pretty good in recursion, okay. So that's why that is the reason, even though it may take time and all that. If they take a lot of time, obviously they have to choose between number of line of codes or the performance. And another thing that you have to remember, that all recursive functions do not take time. Now we are going to write a separate version of this recursive function here itself, which will calculate the same thing in a very fast way. Okay, so again that's the optimization is coming to picture right now, that you written a code, how now it's taking too much time. Now think of the solution, how to reduce the steps. Okay, so that is the part that we are going to look at right away. So let's start with that. So okay, so what kind of things I can observe from my analysis of recursive function? I'm able to find that for I'm calling a same function at least twice, and I'm not storing its value again. So again, if I'm writing a Fibonacci code for 4, it will go to find its previous numbers, and it will call a lot. It's a lot of time. Okay, so it is a waste of lot of memory, that's a lot of stack space, as mentioned by few other people. So when someone saying stack space, that means these functions are actually stored in a memory is divided into 4 parts. In that, the function has been stored in a stack space. So when you're actually writing a recursive code at that point of time, it is copying the whole code directly into stack space. So if I'm calling this for 5 thing, I might be calling the number of functions I'm having is maybe more than 10. That is 10 times I'm calling the same function. So that's the problem I am having with the recursion. So what I will do right now is I will try to reduce it. So if I am able to calculate the value of 0 and 1, I will store it in one single place. And if I am able to find Fibonacci for third position, I will store it in a single place, such that I don't have to look at it again and again. Okay, so that's what we are going to do right now. So what I will do here is I will write another function, private static or Fibonacci 1. Okay, so this concept which someone has mentioned is something called dynamic programming, which you will get to know over the period of time in the course as well. So in that, there is something called as memoization. So what does it mean actually is, I will try to store the values for the aspect which are quite repetitive in nature in the code, in recursive code. Okay, so this is called memoization technique. So what I'm going to store whatever the values are there in a single. Okay, if you can see that now it came, just now it came. So it might be like it took maybe more than 10, maybe around 10 minutes to calculate this thing. So recursive is that bad, and considering my laptop, which is quite old, right? So to save that time, we might be using we will be using this memoization technique, which I'm going to write it now. Let's see if we can complete in next 15 minutes, and let's see how it is going to go. So what I will do is I will just copy paste the whole this thing. I will write it down here. So base condition will be same. If num is less than 1, I'm going to return num. But I'm going to have another aspect here. So I will have it. I will create a variable which is going to store some repetitive words, such that whenever I'm getting a repetitive function, a recursive call, I will just check that whether it's present in that array. If it's present, then I don't have to again call that recursive function. So if I'm doing that, I'm creating a variable called fibonacci as a long array. So what I'm going to do here is I will check this fibonacci, and if it is not equal to 0, I will return fibonacci. Okay, that is now. Okay, so what I am doing here is I'm getting the value, right? So in the like for febrecur 2, if I already have that value in the Fibonacci array, I will just directly just took it. So why I'm comparing not equal to 0 is by default, if I am creating an array, the values will be 0. So if something is which is not 0, that means some values is already been stored there. So if it has been stored there, I will directly take the value and return the value. So that's what it will do. So that's the condition I'm going to have. And another variable I'm going to make a temporary variable. So it's n fibo number. So what I'm going to do, I'm going to replace this Fibonacci, this thing, from here to here. So I will store that in a in this number. I will store the recursive value, what is the formulation, in a variable called of long, that is called nth fibo number. So what I am going to do here is, so for example, if I am getting fibo recur 2, so for this number value I am going to find the values of fibo recur 1 and fibo recur 0, and then I am going to store this value in fibo cache num is equal to and fibo number. So what I am doing is simple. Instead of having return value here, I am going to store this value directly in some variable, and then that variable value I am going to store that in a particular array, such that I don't have to calculate again and again. Okay, and suppose this is the last value of that, I will just fibo number. Okay, and then I will just call recur 1. Okay, let's see it will work or not. And here also I should have something, I guess. I should fibo cache fibo plus 1. Okay, in the main, I just declared it. I just declared a variable here. So I just defined a variable here. Here I am trying to do I am declaring here. Okay. So I think that's it. Let's see how whether it will run or not. First we will see that. Okay, some error will come according to it. Type mismatch. Line 58, we need to change the okay. I need to change. Okay, here I will change number. Okay, thank you. I did that. Okay, if I do this, okay, I got conversion problem where 72. Now plus 1. Yeah, I think it should work fine, I guess. Okay, let's have none for some time. Okay, so I am getting some mismatch conversion problem. Cannot convert long to int. So I should do something here. New line. Okay. Oh, it should be a number. I'll just print it like this. Okay. I will have this long here. Then I will do num plus 1. Okay, so I'm getting a problem, so can anyone can help me? So I'm getting a problem that I'm having a num, so I'm creating an array which is one more than that, such that I will able to accommodate everything. But here num1 is equal to, but it's not accepting here. The function declaration is not accepting. Okay, so someone is writing. Okay, let's try that as well. If I do this, typecast. Yeah, some typecasting problem is coming exactly. So the problem I'm having is, if I'm trying to create an array out of it. So that problem is coming. So for that, I need to find some solution. Any solution that people can think of? Okay, typecast is there. Anything else? So right now I'm creating a long number thing. Can you think of any other way that I can think I can store? Come on, people, can you be able to think of something? Okay, so for that, let's say I will do this. So if I declare num1, can we just pass number1? Okay, so that's the problem is coming. I am having a number. The compiler wants an integer number, but I am passing it as a long number, so it is not accepting it. So if I want to show what's the exact problem here is, cannot convert long to int. So typecast is needed. I understand that part, but why only typecast? I just need to know that aspect. So here I am creating a variable, long variable. So why it will not work here? New long 51. As int is only, we can only type as like a thing because int is only needed. That's true. But if I do int, I will pass it this number as long. Okay, that's the last thing I want to do, but okay, let's try this. If I do int, I will change here. Okay, what I don't want to do, but I'm doing here is, if I'm changing here int, I'm passing int value. I have to pass here also as a int value. I can't pass it long, so that means I can't have a big number. So let's see if we can compromise. So we compromise for that. Okay, I have a different reason for that. I will tell you later, but right now if you can see, for the same recursive function, I'm able to get for the 50th value, I'm just get the value very quickly. If I can, and if I want to run suppose for 60th value as well, so I got an index. Okay, so even though earlier when I was writing for the normal recursive function, it was taking maybe 5 to 10 minutes for that. But now what is happening here is, even I'm storing the value wherever the values are already calculated. I'm storing that value in an array called fibonacci. From this fibonacci, I'm referring here in this code, the highlighted code. I'm looking that if that number exists in that array for the particular position, I will just return it down. So that's how what I am doing. I'm storing, since I'm able to store the value here, I'm able to save a lot of time, which otherwise again what I have to do is, due to recursion, I have to take lot of time to calculate so many calls, which take, as you have seen, lot of time. So this way, one way of optimization that we can do. Unfortunately, this 1 hour is over right now, because otherwise I have seen the same thing for factorial as well, that how we can do the same stuff. but that's what I want to show it here. I think so. We started with a normal iterative function for a Fibonacci series. We see that how it is beautifully working. Then we try to find out a normal recursive function, which find that even though I can write the function in a very less line of code, but it's taking a lot of time. To fix that, I'm writing another function which may be into similar line of codes in terms of iterative, but it is saving a lot of space and calling for me, because I'm storing the values wherever it is needed, so that it doesn't need to call the function every time again and again and again. So that's what the today's session is more about. It's more about how you can write a same code in a different way, basically iterative recursion, and how you can if you find that the problem is if you identify the problem where it's taking a lot of time, how you can solve it. So we in this problem we have solved with using the method of memoization. It comes in a concept of dynamic programming, which you will learn in a separate point of time. But the concept, intuition is very simple. I will store the values wherever it is going to be repeated.